Welcome to the Chapter 6, Part 4 video, where we're going to be looking at rational exponents. So we're going to review the rules for exponents. We've been using them, but we're going to review them together, and then looking at simplifying expressions with rational exponents. Okay, now we've already talked about rational exponents a little bit during the activity that we did. Remember that spreadsheet activity? And we said rational exponents are just another way to write radicals. So that means we can go back and forth between radical notation and rational exponent notation. Let's talk about the terminology I'm using here. When I use the word rational, anytime we think of rational, we have rational functions, we have rational numbers. Rational means fraction. So anytime you hear the word rational from here on out, you should think the word fraction. Okay, so we're looking at exponents that are fractions. So we can write a radical expression in an equivalent form using a fraction or rational exponent instead of a radical sign. In general, the index becomes the denominator of the exponent. Okay, so if I have a square root, the square root has an index of 2, that's being raised to the 1/2 power. If I have a cube root, the index is 3, so that's being raised to the 1/3 power. If I have a fourth root, the index is 4, that's being raised to the 1/4 power. Okay, so let's take a look at the expressions that we're given here and see if we can simplify them. And in order to do that, we're going to relate it back to something we're more familiar with, which is radicals. So here we have 216 raised to the 1/3 power. The denominator is 3. That means this is my index. So we're going to do the third root of 216. If we look at that, the third root of 216, so 216, I can divide by 4. And that gives me 4 times 54. Well, I recognize 54 as 9 times 6. 9 is 3 times 3. 6 is 2 times 3. 4 is 2 times 2. So I can do a cube root. I've got 3 2s and I've got 3 3s. So this equals 2 times 3, which is 6. Okay, so 216 to the 1/3 power is 6. If you do this in your calculator, you can use your calculator to do 216 raised to the, but you have to do the 1/3 in parentheses. Otherwise, what that reads is 216 to the first power and then divided by 3, which will not get you the same answer. Okay, so you can check your answer in your calculator, but again, I want to see your steps, so you can't solve it in your calculator. You can use your calculator to check your answer. For part B, we're doing the same thing, but now we have them multiplied. So the same thing happens if I have the 7 to the 1/2, my index is 2. So that's the square root of 7 times, and then I have again 7 to the 1/2, so that's the square root of 7 again. Square root of 7 times the square root of 7 equals 7. Or if you want to write it as the square root of 49, which is 7 times 7, you can add that step if it helps to visualize it. Anytime we have a square root times itself, it's going to simplify. In part C, very similarly, I'm going to have 2 radicals because there's 2 values here being multiplied together, but this time it's a fourth root. So we have the fourth root of 5 times the fourth root of 125. So I'm going to write this as the fourth root of 5 times 125. 125 is 5 times 25, and 25 is 5 times 5. So we have 4 copies. This equals 5. Okay, so we're just doing radicals again, but instead of writing it with the square root, writing it with the radical symbol, we're writing it as an exponent. Okay, so let's take a look at a couple examples where we want to convert back and forth. We can convert from an nth root or from a rational exponent to a radical. We can go the other way around. And we're going to look at, well, what happens if I have an exponent too? So what if I have something like the cube root of 7a to the third? That was a bad example because it has 3 and 3, 7a to the fourth. What happens with the exponent? Well, the reason all of our fractions in the last one were 1 over the index is because all of our exponents were 1. So when we're looking at something like this, the exponent goes into the numerator, it stays in the numerator, and the denominator becomes the fraction. So 7, 1 over our index is 3. A to the 4th over the index is 3. Okay, so what's happening is our exponent stays as the exponent and the index becomes the denominator of that exponent. So let's look at part A, x to the 3/7. So the 3 is in the numerator, it stays in our exponent. The 7 is the denominator, it becomes our index. So we have the 7th root of x cubed. Okay, y to the negative 3.5. Well, that's not a fraction, but we can turn it into a fraction. So y to the negative 3.5 is the same as y to the negative 3.5 over 1, or y to the negative 35 over 10. Let's go ahead and simplify that. You might have recognized 3.5 as half of 7. You can convert it directly into negative 7 halves. Okay, so if I write this as an exponent form, I would write this as y to the negative 7 under the radical with an index of 2. So we've looked at negative exponents. Let's go ahead and change this. A negative exponent is a reciprocal. So this is the square root of 1 over y to the 7th. Okay, well, 1 over y to the 7th, I can write that as the square root of 1 over the square root of y to the 7th. Y to the 7th, there's 7 y's in there. So 1, 2, 3, 4, 5, 6, 7, groups of 2. This becomes 1 over y cubed times the square root of y, but we don't want to leave a square root of y in the denominator, so I need another square root of y in order to rationalize it. That becomes the square root of y divided by y to the 4th. Okay, so what we had to do, because the exponent was negative, we have to reciprocate. And then we simplified the denominator, but there was still a square root, so we had to multiply it in order to rationalize that denominator. How come I didn't multiply it by y cubed minus the square root of y? This was only one term. I didn't have to do a conjugate. Conjugates are when it's a binomial. Okay, so for this one, I have y cubed times the square root of y. In order to make that a rational number, all I have to do is multiply it by y, or the square root of y. Okay, let's look at our part B. In part B, we're given the radical form. We want to turn it into a rational exponent, so I need to know what the index is. In the first one, our index is 2, so that becomes a raised to the 5 over 2. The 5 doesn't change, just stays in the numerator. And then in our second one, we have b to the 5th, or b with an index of 5, so that's b to the 1/5, and then raise that to the 3rd power. Well, we know that if I have a power to a power, I multiply. If you're not as familiar, we're going to review that in just a second. But that's b to the 1/5 times b to the 1/5 times b to the 1/5. And we know that when I multiply, I add my exponents. So that's b to the 3/5. Notice that's the same as if I had the 5th root of b cubed would also be b to the 3/5. So what this shows us is that it doesn't matter which order we do our index or our exponent, we'll end up with the same answer. So we have a to the 5/2 and b to the 3/5. Okay, so let's go ahead and try what we just worked on. Okay, for part A, if you're not comfortable rationalizing it, that's okay. Give me the answer before you rationalize it, but try rationalizing it. Okay, so part A, you've got 2 answers you're going to give me. Part B, you have 2 answers you're going to give me. Okay, so in part A, our first one, we have a negative exponent, which means we need to reciprocate, which means we're going to need to rationalize. When we're rationalizing, let me fix that to look more like an 8. We need 8 copies of w, but we only have 5, so we need to multiply it by the 8th root of w cubed in order to rationalize that. Our denominator will then be w, and our numerator will be the 8th root of w cubed. For our second part, we have 0.2 as our exponent. 0.2 is 1/5. If you recognize it right away, you can immediately change it into 1/5. If not, you can turn it into a fraction and then simplify that fraction to not have any decimals in it. And then we have the 5th root of W. In part B, we can go directly into the 3 is our exponent and the 4 is our index, so it's 3/4. And then in part B, the second part, we have the 5th root, which is to the 1/5 power, and then that to the 4th power, which gives us an exponent of 4/5. Okay, I will caution you, if you're writing your exponents the same size that you were before and you're writing it 4/5 like this, that looks like multiplication. It doesn't look like an exponent. So I do usually write my exponent fractions kind of sideways so that it's clear that the whole thing is an exponent. Make sure you're careful when you're writing because this looks like a coefficient. Okay, go ahead and pause if you need more time with this screen. So rules of exponents, we've already been using these, but I wanted to remind you, when we multiply two numbers with a common base, we add their exponents. So if I have a to the m times a to the n, that's a to the m plus n. Same thing if it's fractions. If I have 8 to the 1/3 times 8 to the 2/3, I add those to get 3/3, which is just 8 to the first. Okay, if I'm multiplying a base to an exponent to another exponent, right? That means I'm multiplying a to the m n times. So that's a to the m times n. Okay, our example, 5 to the 1/2 to the 4th. Those are both exponents, so I'm multiplying the exponents. 4/2 is 2, so we get 5 squared is 25. If I have two numbers that are multiplied and that's raised to a power, notice this is different. This is not the same as a plus b to the m. We would have to use the binomial theorem for that. But if it's a times b to the m, that's the same as a to the m times b to the m. So if we have 4 times 5 to the 1/2, that's 4 to the 1/2 times 5 to the 1/2. 4 to the 1/2 is the square root of 4, which is 2 times 5 to the 1/2, which we could write as the square root of 5, depending on which form we're being asked for. Okay, if we have a to a negative power, a to the negative m, that's the reciprocal, 1/m. So if I have 9 to the negative 1/2, that's 1/9 to the 1/2, and the square root of 9 is 3, so that would be 1/3. If I have a to the m divided by a to the n, if I'm dividing two numbers with the same base, that means I subtract the exponents because a to the n is in the denominator, so it's negative, right? So we have subtraction there. In our example, 7 to the 3/2 divided by 7 to the 1/2, 7 to the 3/2 minus 1/2, which is just 2/2. 7 to the first is 7. And then same thing goes if I'm dividing two bases to the same power, that's a to the m over b to the m. That's the reason we could separate and combine our radicals if they have the same index. So our example here, 5/27 to the 1/3, that's 5 to the 1/3 divided by 27 to the 1/3. 1/3 power means it's a cube root of 5 divided by the cube root of 27, and the cube root of 27 is 3. So that means our numerator, if we're asked for it in radical form, could be written as the cube root of 5. Okay. If you want a little bit more time on this slide to review your properties, go ahead and pause the video. If you have questions or you want more examples with properties of exponents, just let me know. I have plenty of practice, or you can set up office hours and we can go through this in more detail together. So let's look at a couple of examples where we apply the product and quotient in simplest form. And in order to do this, because the indices do not match, we are going to convert them into rational exponents. So I have the square root of 3, that's 3 to the 1/2, times the 4th root of 3, that's 3 to the 1/4. And in order to do that, in order to multiply these, I need to add the exponents. So that's 3 to the 1/2 plus 1/4. I'm going to write it bigger here, 1/2 plus 1/4. In order to add, I need common denominators. This is why we could only combine with common indices. Okay, so 1/2 and 1/4, my LCD is 4, so I'm going to multiply the first one by 2/2. That's 2/4 plus 1/4, which is 3/4. So I can say this is equal to 3 to the 3/4, or the 4th root of 3 cubed. Okay, to simplify that, 3 cubed is 27. So I have the 4th root of 27. Since the question was given to me in radical form, I will give my answer back in radical form, unless it specifies differently. For part B, the same thing. My indices do not match, so I need to turn this into rational exponent form. This is x to the 3 halves divided by x to the 2 thirds. I'm dividing, that means I subtract my exponents. So I have 3 halves minus 2 thirds. I'll do this down at the bottom, 3 halves minus 2 thirds. I need an LCD. My LCD is 6. So that's 2 over 2 and 3 over 3 to get a common denominator. 9/6 minus 4/6 is 5/6. So that means this is equal to x to the 5/6. And I need to put that back into radical form because it was given to me in radical form. That's the 6th root of x to the 5th. Okay, same thing for part C. I have multiplication, but the indices do not match, so I can't use my multiplication property for radicals. I need to convert this into rational exponents and then simplify. And my first factor here, the square root of 7 is 7 to the 1/2 times the cube root of 7 is 7 to the 1/3. I'm multiplying, so I add my exponents, 1/2 plus 1/3. I'll do it down at the bottom, 1/2 plus 1/3. Common denominator is 6 again. So I have 3/6 plus 2/6 is 5/6. 7 to the 5/6 is the 6th root of 7 to the 5th. I'm going to put that into my calculator to find 7 to the 5th power is 16,807. 16,807. Again, it was given to me in radical form, so my answer should be in radical form unless it specifies otherwise. Okay, I have some for you to try, or one for you to try. So go ahead and try this. So the first step is to convert it into rational exponent form. The 4th root means it's going to be an exponent over 4, x to the 3/4 divided by x to the 2/8. I notice that 2/8 simplifies to 1/4, so that's going to be nice. 3/4 minus 1/4 is 2/4, which again simplifies, so we just have x to the 1/2. So we can write that whole thing as just the square root of x. Go ahead and pause if you want more time with this screen. Okay, so we're going to do this again. We're going to find simplified form, but this time instead of being given to us as radicals, they're given to us with rational exponents. Now, notice rational, we said, means fraction, but sometimes our fractions can be simplified into decimals. We always want to convert them back into fractions when we're doing this. So we have 16 to the negative 2.5. 16 to the negative 2.5 is 5 halves. So I'm going to write it as 5 halves. Okay, I'm going to go ahead and do the negative. Negative means I reciprocate, so that just becomes 1 over the same thing with a positive exponent. So that's 1 over the square root of 16 to the 5th. Now remember, we said it doesn't matter which order you do the radical in, and you can take the square root or raise it to the 5th power first. In this case, 16 to the 5th is really big, but the square root of 16 I know is 4. So that's 1 over 4 to the 5th. I'm still going to use my calculator for 4 to the 5th. And then I find that that is 1 over 1024. Okay, for the second one, it's already given to us as a rational exponent, but notice that 32 is negative. So we have to be aware that that might cause a problem. It's not a negative in the exponent, so it's not going to be a reciprocal. It's actually the base that's negative. So this is going to be negative 32 raised to the 4th power, and then we take the 5th root of it. So there's two things I'm noticing here. First of all, the 5th root, not going to be a problem with the negative number, but it's also raised to the 4th power, so anything to the 4th power is automatically going to become positive. Again, it doesn't matter which order we do the radical or the exponent. I know the fifth root of 32 is going to be a little bit easier than 32 to the fourth and then taking the fifth root of it. So I'm going to say 32 factors into 16 times 2, which is 8 times 2, which is 4 times 2, which is 2 times 2, or maybe you already recognize it as a power of 5. So this is the fifth root of negative 2 to the fifth to the fourth. So this means that I can rewrite this as negative 2 raised to the fourth power. Notice I keep the negative because the fifth root will stay negative. 2 to the fourth power, or negative 2 times negative 2 times negative 2 times negative 2. I know the negatives are all going to cancel out, and that is 16. Okay, most of the time, doing the radical first, finding the root first, is going to be easier than raising it to the power, unless it's not a perfect root. So know that that's an option. If you want to raise it 32 to the fourth power first and then take the fifth root, you're more than welcome to. It's just going to be harder. Okay. Go ahead and try these ones, and then we'll go through the answers together. Notice the first number, I know it's a little hard to read, is indeed a negative 3/5 exponent. Okay, so the first one, I decided to do the reciprocal first. That makes it 1 over 32 to the 3/5. I can now change my rational exponent into a radical, so that's 1 over the fifth root of 32 cubed. I know the fifth root of 32, we just did it in our last example, is 2. So 2 cubed becomes 8, and I end up with 1 over 8. In part B, we have raised to the 3/4 power, so that's the fourth root of 16 cubed. The fourth root of 16 is 2. If you do a factor tree, you can find that, or you can, the powers of 2 are commonly used. So being able to recognize powers of 2 up to the fifth power is going to be helpful. So 2 cubed is 8. In our last part here, 9 to the negative 3/5. Negative 3/5 is 7/2. So 9 to the negative 7/2. I decided not to do the negative first, so we can see if you prefer that method. So this becomes the square root of 9 to the negative 7. Square root of 9 is 3, still raised to the negative 7. So I'll go ahead and reciprocate. That's 1 over 3 to the 7th. 3 to the 7th I did in my calculator is 1 over 2,187. Go ahead and pause if you'd like more time. Okay, we have one more set of examples here. So in this example, we want to write this in simplest form, but now we have coefficients as well. So I'm going to go ahead and write my rational exponent as a radical. We have the cube root of negative 8x times the square root of xy, all of that squared. Okay, now this is a case, because it's all multiplication, it might be easier to square first, because notice I have a square root inside of a square root. So I have the cube root of negative squared becomes positive, 8 squared becomes 64, x squared, and now I have a square root squared becomes just xy. So I have the cube root of 64x cubed y. 64 is 4 times 16, and 16 is 4 times 4. Again, if you factor by 2's or something, you'll end up at the same answer, which is that 64 is indeed 4 cubed. So we have 4x times the cube root of y. In part B, we have, again, something raised to the negative 3/4 power. Be careful with this. Again, it's a reciprocal. So I'm going to do the fourth root of 16y to the negative 8, all raised to the negative 3. I'm going to go ahead and take the square, or the fourth root first. 16 is 2 to the fourth. So this becomes 2y. Negative 8 divided by 4 is negative 2, all raised to the negative 3. I'm going to do the power next. So that's 2 to the negative 3 times y now to the positive 6. So this becomes, let me do my steps here, y to the 6 divided by 2 cubed, which is y to the 6 divided by 8. Okay, step by step. Okay, so your homework is not going to have anything as complicated as that last one. We'll do a couple more together in class that are similar to that last one that we did. But your homework is number 1 through 6 on the lesson check. Make sure you upload the PDF to Blackboard and let me know if you have any questions before class.